Hello everyone, welcome to my channel Yashita Decodes. In today's lesson, we'll be learning about chapter 4 of class 12 computer science, that is using Python libraries. In this chapter, all the topics have been explained in accordance with the CBSE syllabus for class 12. Chapter 4 is prescribed by the NCERT and Sumita Arora textbooks. Okay, let's begin. Introduction. So, Python is a large collection of pre-written code that we can directly use. Okay, so there's so much of pre-written code already present in Python to make users' life easy. So these collections are stored in the form of modules, libraries, and packages. Okay, all this pre-written code that is stored in the form of modules, libraries, and packages. Instead of writing code from scratch, programmers can use the existing code, right? So why do we do it? Because it helps to save time, reduce errors, and improve program readability. So here in this chapter, basically we'll be studying about these modules, libraries, and packages. Okay, what is this pre-written code and what is it all about? So what is a library? So here we say a library in Python is a collection of pre-written modules that contain useful functions, classes, and variables. Okay, collection of pre-written modules that contain useful functions, classes, and variables. And what is a module? Okay. What is a module? A module is a single file containing Python code. Okay, it is a single file which has Python code, and in this file we can have variables, classes, constants, functions, everything. So that particular one single file with Python code that has Python code is a module. And what is a library? A library is a collection of pre-written modules. Okay, collection of pre-written modules that contain useful functions, classes, and variables. These libraries help programmers perform common tasks without writing code from scratch. Okay, so we don't have to write code again and again from scratch. We can just import these libraries. In simple word, a library provides ready-made code that we can reuse in our programs to make development faster, easier, and more efficient. Okay. Python comes with a standard library containing many built-in modules. Okay. Commonly used Python libraries. Python provides many libraries that contain predefined modules and functions to perform specific tasks, such as mathematical calculation, scientific computing, GUI creation, and data visualization. Okay, so we have multiple predefined modules and we have multiple libraries in Python that have predefined modules and functions, and they are used for specific tasks. Like for mathematical calculations, we have a separate module or separate library. Then for scientific computing, we have a separate library, right? For GUI creation, we have a separate library. Okay, all these libraries are created in Python, and some of these libraries are like Python standard library. There's this one such library. The Python standard library is a collection of built-in modules that are available with Python installation. As soon as we install Python, this Python standard library, which is a built-in module, collection of built-in modules, that becomes available to us. Okay, and these modules do not need to be installed separately. Okay, as soon as we install Python, this library comes handy with it. Example of Python standard library modules like math module, random, statistics. We import math module. So in math module, there are multiple mathematical functions like square root, power, and all these functions are already present. So we don't have to write them from scratch. We'll just import this math module because our Python standard library that comes handy as soon as we install Python, and then we can directly use these modules. Okay. Then we have NumPy library. NumPy numerical Python is library used for numerical and mathematical calculations. It is mainly used for working with arrays and matrices. Like if we say import NumPy as NP. Okay, and I'll say array equals to np.array 10, 20, 30. Print array. Okay, so this will give us the output of this array 10, 20, 30. Okay, this will be the array. So what this is doing, np.array is doing, it is helping us create this array. Okay, then 20, 30, this array gets created when we say np.array. So this we can do because we are importing numpy as np, right? And numpy, what is numpy? Numpy is numerical Python. It is a library used for numerical and mathematical calculations. It is mainly used for working with arrays and matrices. Okay, so this is how we import library and this is how we use it. Okay, then we have SciPy library. SciPy is scientific Python. It is built on top of NumPy and is used for advanced scientific and technical computing. Okay, so it is SciPy is like advanced version of NumPy. All the advanced functions for scientific computing that are present in SciPy library. Then we have Matplotlib library. Matplotlib is a library used for data visualization. It helps in plotting graphs and charts such as line, bar. So if you have any exposure to data science, so you see that we use all these libraries there. And Matplotlib library is a very important library because we use it for creating graphs, right? We want to see the trend or something, then we can import Matplotlib library and then we can, with the help of it, we can create graphs, related graphs. Okay. Okay. Next is, what is a module? A module is a single file containing Python code, right? It may include functions, variables, classes, constants. Like it is a simple file containing Python code. And it has functions, variables, classes, constant. And when we have this collection of module helps creating a library, right? So example of module is like math.py, random.py. All these are modules. And these modules like math.py, random.py are part of Python standard library, right? Its contents can be reused in other programs without having to rewrite them. For example, like if library is a book, then a module is one chapter in that book. Okay, so this is the analogy, simple analogy to understand this. That like if we have a book, then that is a library, and all those single like chapters inside that book, that is a module. Okay, like when we say math module, we can say like when we do math dot square root of x. Okay, so this math dot square root, this square root, that is a function or that is present in that particular module, and we can directly import this function to perform the square root operation, right? Similarly, we can do math dot power. Okay, let's say we want a power of 2 raised to the power 3, which will give us the output 8. Okay, so here this power function, that is also part of this math module. We can use this power function directly, right? Now, structure of Python module. A Python module is generally divided into following parts. Like we have documentation string, doc string. It is written at the beginning of the module to explain the purpose of the module. It is written inside triple quotes. Okay, so what is a documentation string? We basically do it in order to explain like what this program is about, or if we want to write something in the starting of the program in order to make it easier for the user to understand what this particular thing is all about, right? So documentation string. Import statements. It is used to import other modules and libraries placed after docstring. Like we say import math. So we are importing this particular module, right? So it is used to import other modules and libraries. Then we have global variables. Variables defined at the module level. These are accessible throughout the module. Example, pi is equals to 3.14. So these are the variables that are present at the module level, right? So whatever global variables are present, they can be accessible throughout the module. Then we have function definition. Contains functions that perform specific tasks, improves code reusability. Like we say define area circle and we return pi r square, right? So what is this saying? That this is a function, contain functions that perform specific task. Like here This area circle function is returning the area of that circle, right? So these are function definitions. Then we have class definitions. Like if this particular, like if we've created a particular class in that module has a particular class, let's say our module has class called circle, and inside that class circle we could have multiple functions related to that, related to circle, like printing, like defining the radius, printing the area, or calculating the perimeter. So these are class types. Then we have executable statements in main code. Code that runs when the module is executed directly, often written using if name equals to main. Okay, these are executable statements on main code. Okay. See here, this part inside these quotes: module name, geometry.py, purpose, calculate the area of a circle. Okay, so we have defined our module name. Okay, and then we are defining the purpose is calculating the area of a circle. So here, this is the doc string, right? This is describing what this module is and what is the purpose of this module. Then we have import math. We are importing this statement, right? Then we have pi is equals to 3.14. This is the global variable, right? Then we have defined this area circle. Area circle, we are returning the area of the circle, pi r square. This is the function. Then again we have class circle. We are like in this, here we have created this particular class, and inside this class we have defined this variable self, like self.radius equals to radius. So like what is the radius we're defining. Okay. And then finally we have this main code, name equals to main, area is equals to area circle, right? Okay, so next is importing modules in a Python program. Python provides multiple ways to import modules. Like first is importing entire module. Like with the help of like this statement, import module name, we can import the entire module, right? Then we have importing select objects from a module. From a module, import object name, like import single object. So from math, import pi. So we are importing this particular pi object. Okay. And we can also import multiple objects. Like from math, import square root or power. So we can import these multiple objects. Import all objects. So we say for module, import this star. So when we say import star, so it imports all the modules, okay, all the objects of a module. So this is how we do it. And in order to import the entire module, we simply say import module name. Now next is Python's processing of import module command. When a module is imported in a Python program, Python performs a fixed sequence of steps to make the module and its content available for use, right? So here we're discussing processing of import module, like what all steps, like what happens when we import module. So first is namespace. So what is a namespace? A namespace is a mapping of names to objects. It helps Python identify which name refers to which objects and avoid name conflicts. Okay, so Python identify which name refers to which object and avoids name conflicts. So like here, when we say import, like if I'm importing this particular math module, like I say import math, I'm saying math.py, right? So math.py, when I say the way I say math.py, because this pi is a part of this particular math module. So in order to avoid name confusion or name conflict, I say this, right? So that is what it is saying. Python identify which name refers to which object and avoid name conflicts. This namespace, this helps Python identify which name refers to which object and avoids name conflicts, right? Now types of namespace. Built-in namespace contains built-in functions like print, length. Then we have global namespace, names defined in the current program. Module namespace, names defined inside the module. Okay. Namespaces avoid confusion between same variable function names and help prevent name conflicts. Okay, that is the purpose of namespace. Okay. Now processing of import module command. When Python encounters an import module statement, it searches for the module in the current directory in the Python standard library directories. So first step is to search for that particular module, right? Then it loads the module. Once it has found that module, it will load the module. All the statements present in that module once are there. It will load all the statements present in the module, right? Then it creates a module namespace. All variables, functions, and classes of the module are stored here. A module namespace is created. All the variables, functions, classes, they are stored in the namespace. Then it creates a reference name. Module name becomes a reference to the module namespace. Okay. Then accessing members. Members must be accessed using dot operator. Like we say import math, then we say print math dot square root. We're not saying print square root, we are saying math dot square root, because square root is a function of math module. Okay, and the namespace when it is created, so in order to access those members, we use this dot operator. So these are all the steps. Next is processing of from module import object command. From module import object name. From module name import object name. So when this statement is executed, Python searches and loads the module if not already loaded. Okay, so it will search the module and then it will load the module. It copies the specified object. So we will not be loading all the objects. We'll be only like once it has loaded the module, we'll not copy all the objects. We'll copy the specified object. The object is copied directly into the current namespace, right? That particular namespace will be created, and that specified object, which the object we have specified to import, that particular object will be copied. No module name is created, only the imported object is available. In that particular namespace, imported object is available. So when we say from math import square root, so from this particular module, we are importing this square root. So only this square root object will be copied in the namespace. So we'll say print square root itna. Square root 25. So we are not saying math dot square root. We are only saying square root because we are only copying this particular object. So here dot operator is not required. Okay, math dot square root is not required. Math namespace is not created. We are only in the namespace, only this square root object is copied. Okay, so this is the difference when we say from module name import object name, or when we say import module name, when we are importing the entire module, or if we are importing the particular object from that module. See, here we have this example. We say import math from math import pi. Okay, so when I say math dot square root, so I'm using this square root function from math module. So I'll say math dot square root because I'm importing this entire module. In this, it creates a namespace where all the objects will be there. So I'll have to, in order to access via module namespace, I'll say math dot square root. And here when I say math dot import pi, so here in my namespace that will be created here, it will only have this object pi. So I'll say print pi. Okay, I'll directly access it. So this is the difference. Math is module namespace, pi directly imported into current namespace. Okay. Next we have Python built-in mathematical functions. So we have all these mathematical functions like length, power, string, int, float. Okay, so what is length? It returns number of elements. Like we say when length of object, length of Python, the output is 6. Why? Because we calculate length of Python. Here it will calculate this length and the output it gives is 6. Then we have power, returns x raised to power by. So when we say PO power, POW xy, POW 2 and 3. So we say 2 raised to power 3 and it gives me the output 8. Then we have string. It converts value to string. So when I say string 10, so it will give like 10 inside quotes. Okay. Then we have int, converts value to integer. Int 12.9, it will give me the value 12. Then we have float, converts value to float. Float 5, it gives value 5. Then we have range, generates sequence of numbers. range, start, stop, step. So we have range 1 to 5. So it will give us output 1, 2, 3 and 4. So we'll range is like what is the start? Start is 1. What is the stop? It stops at 5. And step, by default step is 1 only. So it will give 1, 2, 3, 4. It generates a sequence of numbers. Okay. Type returns data type. Type object type 3.5. So it will give me what is the type of the object. It will say float. Absolute, return absolute value. Absolute minus 9 and it will give me the value 9. Okay. It gives the absolute value. Then div mod, it returns question and remainder. Div mod AB, like if we say if division mod 17.5, so it gives 3 and 2. Then we have all these sum iterable argument. Sum iterable is sum of elements, like sum of 1, 2, 3. So I'll just show you on Python how all these functions are behaving. All these mathematical functions behave, and then you'll get the better idea. Okay, so we'll be looking at the mathematical functions. So let's say I have this array nums 2, 3, 2, 4, 6 and 8, and I am printing length of list. I'll right click here and run it. So it gives me output length of list is 4. Okay, 1, 2, 3, 4, right? Then let me print 2 raised to power 4. Okay, so I'll say POW 2 and 4. Okay, so the output will be 2 raised to power 4 is 16, right? Then if I say print integer value int, I will print integer value int 12.9. So it gives me integer value 12 because it will convert this decimal value into integer value. Then if I say print float value, float of 7, and I'll print absolute value, abs minus 20. Okay, so here I'll right click. It will give integer value is 12, float value is 7.0 because it has converted this integer value 7 into 7.0 float value, and absolute value is 20. Okay, now next, if I try to find the range, then range values list range 1 and 6. Okay, so the next is print type of 10. Okay, so if I say type 10, okay, so it will give me result type of 10 is class int. Okay, next is div mod. So print quotient and remainder. Okay, and I'll say div mod 25 4. So I'll right click and check. The answer is quotient and remainder is 6 and 1. Then I'll say print sums of list. Sums of list, this is sum nums. Okay, so I'll right click and it gives me sums of list 20, because our list is 2, 4, 6, 8. 8 plus 2 is 10, 6 plus 4 is 10, 10 plus 10 is 20. Okay, and if I say print sums with start value, sums with start values, sum nums and 10. So I'll right click sums with start value, so it will add the sum of nums with and 10. So sum of nums was 20 plus 10 is 30. Okay, then if I say print maximum iterable, max of nums, so it will give me the value max iterable is 8. So 8 is the maximum value here. Now if I say print maximum arguments, I say max 5, 12 and 7. So the answer is max of arguments is 12. Then I say print minimum iterable, minimum of nums. So here I'll right click and the output is minimum iterable is 2. Why? Because we have numbers 2, 4, 6, 8 and 2 is the minimum. Then I say print minimum arguments. Then we have min 5, 12 and 7. So the minimum, so answer is minimum argument 5. Okay. Then we have print octal of 16. Octal of 16. We have oct 16. And if I right click, oct of 16 is this value. Okay. And here we have print hexadecimal of 16. Then we have hex of 16. So hexadecimal of 16 is 0x10 1. Okay, so these are the mathematical functions, right? Then we have Python built-in string functions. So Python built-in string functions, we have join sequence into strings. So we have joins like hi all. So we get this output when we do join. Then we have split. We can split this hi all into different words like hi and all, and then we can replace substring also. Like we can replace cat. When in this cat we can replace C with B, so cat becomes bat. Okay. So let me just show string. Okay, we'll just see string functions now. Okay, let's say we have this sentence, which is Python programming is easy. So we print length of string. Length of sentence. So if I'll right click here, it gives me length of string is 26. Okay, so there are 26 characters here, right? Then I say words is equals to sentence dot split. Okay, so we say print split string words. So split string, so we have, when this is sentence dot split, we are splitting this particular string, so it gives Python programming is easy. All these different words are splitted. Okay, then we have new sentence join words, print join strings. New sentence, we have joined words where we're joining it with this dash, so it says Python programming is easy, and this instead of space we have this dash here, right? Then I say changed sentence, sentence dot replace easy with powerful. So I say print replace string change sentence. Okay, so here if I print it, it says Python programming is powerful. Earlier it said Python program is easy. Now we have replaced this easy with powerful. Okay, now if I say number is equals to 100, print number as string str number, print type of sentence, type sentence. So here we see number as string, string number 100, and type of sentence is class string. Okay, so these are the string functions. So the next topic is working with some standard library modules. So first is random module. So the random module is a part of Python standard library. Okay, it is used to generate random numbers. To use random module, we must first import it. Like we do it with like import random. When we say import random, random module gets imported, and it is a part of Python standard library. Okay, so these are some of the functions of random module. Like when we say random dot random, so it generates a random floating point number between 0.0 and 1.0. So between the range of 0.0 and 1.0, it generates a random floating point number. Okay, so here when we say random to random, the output is 0.63, which is in between 0.0 to 1.0, right? Then we have random dot rand int ab. So it returns a random integer between a and b inclusive. So when we say random dot rand int ab, any random integer between a and b. So let's say if a is 1 and b is 10, so here the output is 7, so it could be anything between 1 to 10. Then we say random dot uniform ab. It returns a random floating point number between a and b. Okay, so here in rand int ab, it was returning a random integer, and here random dot uniform, it is returning random floating point number. Okay, So when we say random.uniform AB, random.uniform 1.5 to 5.5, the output is 3.84. It could be anything between 1.5 and 5.5, any floating point number. Random.randRange returns random integer from 0 to stop. Random.randRange stop. So when say random.randRange 10, so here we have this value 6. When we say it says 10 stop -1. So here randRange is will start from 0 and it will go up to 9. 10 is not included. Okay. Now random.randRange start stop step. So it returns a random integer from given range with optional step. We say random.randRange start stop step 222. So the output is 14. It gives a random integer from given range with optional step. Okay, so given range is from 2 to 14, anything in between. Okay, so I'll just show you on PyCharm how it's done. Okay, so first we'll import random. Okay, so if I say print random float random.random. Okay, so I'll just right click here and run it, and random float 0 to 1 is, we got this random number 0.31. Okay, so because it is generating any random floating point number between 0 and 1. Now print random integer 1 to 6. So here I say random dot rand int 1 to 6. So it gives me random integer. Okay, so rand int is for integer. So it gives me random integer anything between 1 to 6. So it gave me 4 output. Next is print random float 10.5 to 20.5. Random.uniform so random float, it says it gave me output 13.28. Okay, so any floating number within this range. Okay, next is print random number 0 to 9. Random dot rand range. So it gave me number 1. So anything in this range 0 to 9, because we have given rand range 10. So it starts from 0 and it will go up till 9 because 10 is not inclusive. Okay, 10 minus 1, 9. Okay, so then next print random even number 2 to 18. To 22. Okay, so here it is given this even number 4. Okay, starts at 2, stops at 20, and any step is 2. So any even number it will give me from between 2 to 18, because 20 is not inclusive. So one number with a step of 2 minus 2 is 18. Okay, so I'm just giving me 4. String module. Okay, so using string module, we just saw random module. Now we are looking at string module. So string module is a part of Python standard library. Again, this is also part of Python standard library. Random module was also part of Python standard library. It provides useful strings, constants such as letters, digits, and symbols. Okay. To use the string module, we must first import it using import string. The same way the way we import any module. Okay. So these are the string module constants with output. So these are the functions like string.sky letters. It contains all English letters. So see, here we have written ABCD till Z in small letters and ABCD till Z in caps. Okay, so all the English letters. Then sky for lower case is contains lowercase letters. Okay, then sky for uppercase, it contains uppercase letters. See here, all are in uppercase. Then string dot digits, it contains decimal digits. Okay, so here these are the decimal, these are the digits. Okay, then we have hexadecimal digits when we say string dot hex digits. Okay, so from 0 to 9, then ABCD, EF in caps till here. So it will help in creating hexadecimal digit. Then string.octdigit contains octal digits. String.punctuation contains punctuation symbols. These are all punctuation symbols. I'll just show you on PyCharm and it will become more clear. Okay, so first of all, we'll just import this module string. We'll say print string dot sky letters. Okay, I'll just right click here and print it, and see, these are all the these are all the sky letters. This is from ABCD till Z in small and then in caps. Okay, then I say print string dot sky lowercase. Here, see, this is the output, ABCD till Z in lowercase. Then if I say print string dot sky uppercase. So here this is the output, all the letters in uppercase. Okay, I'll just copy these out. Next, I'll say print string dot digits. I just right click and run, and it has given me all the digits 0 to 9. Okay, then I'll say print string dot hex digit. I'll right click here, and here these are the hexadecimal digits. Okay, then I say print string dot so these are the octal digits, and then I'll print string dot punctuation. Okay, so what do I get? All the punctuation letters. Okay, all right. Okay, so the next topic is creating a Python library. In Python, a library is a collection of modules, and a package is a collection of related modules arranged in a directory structure. Okay, so like we have already studied, like Python is, in Python, library is a collection of modules. Module is a py file, Python file, which has Python code. Okay, so library is a collection of modules. And what is a package? Package is a collection of related modules arranged in a directory structure. Okay, like structure of a Python package. A package is a folder directory that contains Python modules and a special file named init.py. Okay, so here, like, this is the Python package. See, like, this is my package. We have created my package here, and here it has this module1.py file, module2.py file. So these are like let's say these are two related files that we want in our package, and then we have this init.py file. It is so a package always has a init.py file. Okay, so why do we need this init.py file? So that init.py file is used for initialization and managing the package's namespace. Okay, that is why that is the significance of init.py file. And in order to create a package, we always need to have a init.py file. Okay, so it is used for initialization and managing the package's namespace. Okay, now procedure for creating a Python package. So first of all, we create a folder, create a directory that will act as a package. Let's say matlib. Okay. Then we create init.py file. Inside the folder, create a file named init.py file. Okay. Create module files. Create one or more py file inside the package. Like this is, let's say this is the example of package matlib. So inside this package matlib, we have one init.py file and we have operations.py file. And inside operations.py file, we have defined these two functions, add and sum. Okay, this is how a package, Python package, looks like. Okay. Now the next topic is using importing Python libraries packages. So once the package is created, it can be used in a Python program using import statement. Like import entire module. So when you want to import entire module, we say import matplotlib.operations, and then we say matplotlib.operations.add. So because we are importing this entire matplotlib.operations module, so if while accessing its functions like add function, we have to specify matplotlib.operations.add. Okay. If we say import specific function, so from matplotlib.operations import add. So we can just directly call this function print add. Okay. So next is import module with alias. Import matplotlib operations act as op. So while using any function here, we say op.sub. Okay, because we are using this alias here. The alias that we are using for operations is op. Okay. So here a package is a directory. Fine. Init.py is mandatory to define a package. A library is the collection of packages and modules. Packages help in better organization and reusability. So I hope this part is clear. And I hope we have understood why we need init.py file. Okay, so init.py file is a Python file that is executed when the package is imported. Init.py is a special file used in Python to define packages and initialize their namespace. It can contain an initialization code that runs when the package is imported. Without this file, Python won't recognize a directory as a package. It serves as two main purposes. It marks the directory as a Python package so that the interpreter can find the modules inside it. It can contain initialization code for the package, such as importing submodules, defining variables, and executing other code. So I have read this part from Geek for Geeks. If you have any confusion, you can also refer that site. They have explained entirely why this thing is needed. Okay, so the two main purposes are: it marks the directory as a Python package so that the interpreter can find the modules inside it, right? And it can contain initialization code for the package, such as importing submodules, defining variables, or executing the code. So that is the purpose of init.py file. So whenever we define a package, we always have a init.py file. Okay, and without this file, package won't recognize a directory as a package. Okay. So I think this chapter is done, and in this chapter, like, we learned about Python libraries and modules which provide predefined functions, case classes, and constants to perform common programming tasks efficiently. We studied the concept of modules, packages, namespace. Okay, I hope all these topics are clear. What is a module, what is a package, library, namespace. Okay, this chapter also covered the use of Python standard library, including built-in mathematical functions, string function, commonly used modules such as random and string. We saw both those modules, random and string. We saw the functions of those modules. Finally, we learned how to create our own Python libraries using packages, which helps in organizing, reusing, and maintaining code. Python libraries make programming simpler, faster, and more structured, enabling the development of reliable, efficient program. Okay. So I hope this part is clear, this chapter is clear. If you are finding anything difficult, or if you want me to explain anything separately, then do let me know in the comments. Thank you. Happy learning.